My name is Nikhil.
I'm Daniel.
So we're from the Google Brain team. We work on PAIR, which is People in AI Research. So we're here to talk about TensorFlow.js. TensorFlow.js, as it sounds, is a JavaScript library for machine learning. It's part of TensorFlow. And we'll kind of go into some of the nitty-gritty details of that. So our talk is called Bringing Machine Learning to the Web and Beyond, and we'll talk about what beyond means in a sec. Nice. Okay, so I don't have to convince people in the room here. We all know that Python is the dominating language of machine learning and data science. This is a Katie Nuggets software poll that polls people about what sort of libraries that they use and languages they use. Python dominates. We all know this. There's good reason for this. There's lots of libraries and tooling and educational coursework around that. At the same time, the rest of the world sort of works in JavaScript. By most popular language by pull request, we see that JavaScript absolutely dominates. And so we kind of wanted to bridge these two worlds, and we think that there's a lot that JavaScript has to offer to machine learning. And this poll was actually done by GitHub. Okay, so have people seen this before? Playground.tensorflow.org? If you haven't, I would definitely recommend checking out. It's super cool. Daniel and a couple other people at Google built this. It's an in-browser interactive visualization of a neural network training. You can go and choose a synthetic data set, change hyperparameters of the model, the activation function, learning rate, all that kind of stuff. And you can see immediately on the right how it generalizes for that data set. And this is just kind of a lot of fun, so I definitely recommend checking this out. And this thing was a huge educational success. This is actually used in courses all over the world now, and I think Daniel still gets emails about this to this day. So we were kind of stepping back, and we were wondering, what was it that made this so successful and so popular? And we think, obviously it's because it's an in-browser machine learning application. And in-browser ML has a lot to offer, right? So you just click a link and you're there. There's no CUDA installation. There's no wrangling with Python dependencies. You just click the link and it's open. And it runs on pretty much any machine. This one was super interactive, right? Like you can immediately click different activation functions and choose how many neurons are in each layer and immediately see the results. So this is a ton of fun. We didn't take advantage of this in the playground, but your device has all these sensors, and there's standardized access to the sensors through web APIs. So you have camera access and GPS and microphone, all these kind of things. And importantly, the data can stay on the client. So we can do privacy preserving on-device machine learning with this kind of thing. So with that, obviously, we released a library called TensorFlow.js. This is part of TensorFlow ecosystem. We released it last year in March in 2018. In the browser, we do GPU acceleration with WebGL. If you don't know what WebGL is, it's a web-based graphics rendering library, normally to put a 3D scene on the page. It turns out that the math for that is very similar to machine learning, so we took advantage of those kind of shaders to do all of our linear algebra. TensorFlow.js allows you to do inference, so you can take pre-trained models from the Python world, and just execute them, or you can train entirely in the browser and Node.js and even more platforms, which Daniel will talk about soon. Okay, so when we built the library, there was a couple goals, two sort of overarching goals. One is that we wanted to take these JavaScript developers and sort of empower them, give them sort of the ML tools that they would need to succeed in this space. At the same time, we wanted people with a machine learning background to be able to port their work to the web and sort of have a fully featured library there. And these goals are kind of often at conflict with one another. Like you want to make it simple, but you want to make it fully featured. So we'll talk a little bit about the decisions we made to resolve that. So two overarching principles that we had are we want it to be super easy to use. So like we just want people to get started and just start going. And we kind of sometimes decided to take a hit on performance for those reasons. And we'll talk about a couple of decisions there as well. Again, we don't want to sacrifice functionality for simplicity. So those are two overarching principles. We decided to go eager only. So from the very beginning, we've never had a graph. We've never had session APIs. We just said eager. This is a lot simpler to sort of wrap your head around. This is when TensorFlow 1.0 was out, so it was all graph-based. So we also have first-class support for Layers API. This is Keras inspired. This is what we tell people that they should probably use if they're getting started. This is completely compatible with Keras. It provides serialization, ability to add layers and that kind of thing. And then even on top of that, we have a whole repository which we're working very hard on to provide pre-trained models like PoseNet that give you a tensor-free, no machine learning jargon API. So you just kind of get a JSON object out from an image element, which is pretty nice. At the same time, so we focus on performance here where it matters. So what this means is We make sure that our map models are fast, we make sure our comms are fast, but we're not going to force the user to have to take that burden. So we provide gradient support. So on device, you can actually train models, compute gradients. We have an eager-based training API, just like TensorFlow does. We support about 130 TensorFlow ops. And for those models that we talked about above, so for PoseNet, if you want to do transfer learning, you can actually reach in and get the tensor out. So it's not just completely wrapped for you. So if you want to do something like that, you can. Okay, so what can you do with the library itself? So there's kind of the spectrum of like easy to hard, and that's subjective, obviously. But sort of on the easiest side, you can take a Python model that's been trained already, and you run a script, and you get a bunch of artifacts that you have for the web, and you can just make predictions on those. So right there on device, and you can do that in the browser or Node, et cetera. You can also retrain those models. So once you have that model in the browser, we have APIs for fitting for data that may be on your webcam or from your microphone or anything else. And this is sort of in the middle. And on the harder side, is writing the model entirely in JavaScript. So what this means is we have a full library for stitching together your own model and training it in the browser. Okay, so just a quick high-level architectural overview. These are sort of layers of abstraction. At the very, very highest, we have that models. These are pre-trained models with nice, easy APIs. We put them on NPM. We host all the weights on GCP for you, so you just have to NPM install, and everything comes for you. We have this layers API. This is Keras compatible API that lets you stitch together layers, serialize models, and that kind of thing. And then our core API below that is linear algebra kernels. These are all GPU accelerated, and it's all eager-based for gradients. In the browser, as of today, Daniel will talk about some future stuff, we sit on top of WebGL. Again, this is the graphics rendering library. And in Node, we actually bind to the TensorFlow C++ binary, and we can get acceleration with GPUs and CPUs and eventually maybe TPUs. So these are completely compatible with one another, which is pretty cool. And we have the ability to take models from Python and import them into the browser for execution or retraining. So that's kind of the high-level view of what TensorFlow.js looks like. So I'm just going to poke into the models repo really quick. So if you haven't checked this out, go check out that GitHub repo. There's a bunch of models there, a bunch of different modalities. I'm going to just show you how easy one of them is. So the model I want to point out is a human segmentation model. And so this human segmentation model is called BodyPix. And the goal of this model is for every pixel on the screen, just tell me if that pixel is part of a human being or not. It's very simple, conceptually. And also we give body parts as well. So it'll tell you if this pixel is part of an arm or a head or that kind of thing. So this is kind of what the output of that model looks like. So I'm going to try to show you how easy this is to get going. So all you have to do is script source TF.js and BodyPix, two things we host for you. And this is a fun little visualization by Dan. These are also in NPM, so you can NPM install those like that. And the first line, it's 2 lines of code. So the first line is you await bodypix.load. This downloads all the weights from GCP for you and puts it in this little net object. And then you just call estimate single person segmentation. And that image object right there is actually an HTML image element. So like a regular query selector on an image. And you get this segmentation object out, which is a JSON object. That's it. And it has all the mask information in there. And we also provide a bunch of utilities inside of those to help you draw things like this. So we can do background blurring for you or like coloring of your body parts and that kind of thing. So that's BodyPix. I definitely recommend checking it out. We have a bunch of other models as well that have very similar APIs. And with that, I'm going to hand it off to Daniel.
Thanks. So when we started this project, we were initially focused on the browser. And a lot of people, when you hear JavaScript today, the first thing you think is the browser. But modern JavaScript is so versatile and so powerful that it runs on all sorts of platforms. And to give you some idea, obviously we all know the major browsers here, but we know that there is Node.js that makes JavaScript compelling for server side. There is Electron, where people use to build modern desktop applications like Slack. And what was surprising to me also in the last 2 years as I was learning more about this is that more and more platforms, there's more and more hybrid apps that allow you to write JavaScript and then deploy to a mobile device. So like WeChat, React Native, and Angular in conjunction with NativeScript allows you to do this. So the orange boxes are the platforms where TensorFlow.js runs today. And I just want to quickly go over some of these platforms and showcase a few interesting real-world examples that use us. So on the browser, there is this Creatability project, which is a set of experiments by Google to explore how to make creative tools to be accessible by everyone, so people that have impairments. And they're using all of the sensors on the laptop, like the microphone and the accelerometer and the camera, to allow people to express themselves. Uber Manifold is using us, also in a web app. Their web app allows you to analyze an ML model and compare two ML models together. But a lot of the computation, so it has a server, but also a lot of the computation to make it super fast and interactive is done on the browser itself. And what's interesting here is they don't use us as an ML library. They actually used our lower level ops like MathMouse and other linear operations to do fast linear algebra because we accelerate on the GPU. And the third example I want to showcase is more of the classic example of using us in the browser. Airbnb has a web page. They ship a model on that web page that when you're trying to upload a profile photo on device, it tries to run a simple image recognition model that warns you if you have some personal or sensitive information. Turns out a lot of people are scanning their government IDs and uploading them as profile photos. So Airbnb warns you on device, and the reason why they're doing this on device is it's much simpler for privacy reasons than to upload this and analyze it on the server. On the desktop side, especially with Electron, I want to showcase two examples. So Clinic.js is a desktop application that allows you to monitor your Node.js application for CPU cycles, for memory usage, and they actually use a TensorFlow.js model with the power of machine learning to distinguish between memory use done by the kernels of Node.js itself versus your app, your user app. Magenta Studio is also an interesting example. So what they provide, Magenta is a team at Google Brain that explores how machine learning can come together with music and music generation. So they have a few models that can generate music and music sequences. And they built plugins that plug into Ableton so that allows musicians to quickly interact with machine learning and augment their creativity. And what's interesting here is that Ableton has a plugin system, and all of the plugin system is powered by Electron. So it's very interesting that you can write JavaScript applications. We've heard similarly for Photoshop that Photoshop has nowadays filters or plugins that you can augment in Photoshop via Node.js. And the third example I want to showcase is WeChat. So this is on the mobile side. So WeChat is a mega popular, it started as a chat app, but it's a mega popular platform nowadays. It has more than 1 billion users, mostly in China. It has over 1 million mini programs. So this is very similar to the Apple Store. And it turns out that you can write a mini program using JavaScript. And we actually recently released a plugin for TensorFlow.js that allows you to run models in WeChat. And this in particular one is a makeup app that allows you to overlay makeup and quickly see. All right, so those are the few examples. I just want to briefly touch upon 3 other projects that are around our library. So TF-Data, TF-Viz, and some node updates. So TF-Data, for those of you that have used Python, this is analogous to TF-Data in Python. It's a library that allows you to construct data processing pipelines, such as batching, shuffling, filtering. And the secret here, or not the secret, but the gain that you get is that all of these transformations are done lazily. So you can work with data that doesn't fit in your main memory. TF-JS Viz on the browser side allows you to visualize interesting, to gain interesting insights about your ML model. So it has this hideable drawer called the visor, and you can place in charts that we provide. We provide a bunch of built-in charts, but we also give you high-level visualization methods to visualize layers and filters and some properties of your training data. And lastly, we also give you built-in evaluation utilities, so you can quickly plot accuracy or confusion matrix or AUC curves. All right, so on the Node.js side, Nikhil mentioned previously that we are not constrained by, when we're server-side, unlike the browser, we don't have a sandbox. We can bind to any library. So we bind to the TensorFlow C library, and we get the full performance of TensorFlow for CPU. And if you have CUDA installed, we can benefit, we can utilize your GPU efficiently. And this is great for servers. However, we're also working on a headless GL backend for Node.js. And we're very close to releasing this. And the reason why we're working on this is because we want to make sure that if you are writing an Electron app, you can take advantage of the GPU, even if you're on Macs or you don't have CUDA drivers installed. And also, the package is much, much smaller compared to downloading the full TensorFlow library. Lots of libraries started using us, and I think that's just amazing. So a few of a few libraries here is the Face API, HandTrack API, ML5.js. Check it out also if you're more beginner machine learning. It's a great library to start because it provides more high-level APIs. And I just want to say thanks to all of the libraries that are using us, and they're helping us make TensorFlow.js better. So we launched this about a year and a half ago in March 2018, and we've been getting lots of momentum. We have a lot of NPM downloads. We have almost 200 contributors, and I think it's pretty exciting. Everything is open source, and I just want to also thank the community for actively helping us make this better. All right, so on the future, we're working to extend our hybrid native platforms. So we're working on a React Native plugin so that if you're a React developer and you're using React Native, you can load a model and make prediction in a native app. And this is coming very soon. On the side of trying to make machine learning more accessible, we are integrating, we're working on an integration with Cloud.ml, as you've seen before, where you can train a model without having to do any coding. And then you will be able to download the TensorFlow.js version of that model if you're using the Edge product, and then just run it in the browser. We're also constantly looking for new models, pre-trained models that are useful out of the box to add to our models repo. So we're working on object segmentation model, for example, that we are planning to release in the next month or so. On the performance side, performance can always get better. So we're actually working and have prototypes on two different technologies. So WebAssembly that helps us accelerate our computation on CPU because not all devices have GPUs, not all devices have WebGL drivers or drivers that can run WebGL. So WebAssembly is going to help there. Everything is open source. We just started this, but feel free to follow and also make contributions. And on the GPU side, there's a new platform coming in, WebGPU, that gives us much closer to the metal access to the GPU. So we should be more performant than WebGL. And this is, I would say, still at least a year out, if not longer, for all browsers to adapt. But it is a standard that has been accepted by all the browsers. So it's pretty exciting. There's also a book. A few of our wonderful colleagues are working on a book that's going to come out, I think, somewhere in the fall. So you can pre-order it now, and you can use this coupon code to get a discount. All right, so I'm very optimistic about the future of machine learning on the web. 2 years ago, none of this was possible. We didn't even think that we could be doing something that can be performant and fast in JavaScript. But today, it is very obvious that things are moving at a high pace. And there are 3 things that are driving this progress. There's new web standards coming in, like WebGPU, WASM, which stands for WebAssembly. There are potentially new specs like WebNN, like a neural network spec. All of this would give us closer to the metal access to do faster computation. There's another also force, and that is just ML research. ML researchers are coming up with more efficient architectures. For example, MobileNet v2 has half the flops of MobileNet v1, but almost the same accuracy. And now with AutoML and neural architecture search, you can let computers find the most optimal lightweight model that can do the task for you. And the third avenue where this is pushing is us working on optimizing TensorFlow.js itself. In the last year, we've made a lot of progress. We've became more efficient at packing WebGL textures, fusing ops, so we minimize calls to the WebGL backend, and etc. So all of these three things combined, I think, makes the web move really fast. Everything is open source, and we have a wonderful website. Please check it out. We are also on GitHub, and we have a mailing list. And I just want to say that the work that we've shown here was created by lots of different people, both inside and outside Google. We have a lot of amazing open source contributors as well. And we are hiring a developer advocate. If you're passionate about JavaScript and machine learning, here's the link to the application. And thank you.